So let us start the derivation of average value. So if they ask you the definition, so first and foremost, before going to the derivation of average value, they will be asking you the definition of average value. So what does the definition states? So the definition states that the average value of an alternating quantity is defined as that value which is obtained by averaging all the instantaneous values over a period of half cycle. So it means if I see this diagram, in this diagram I am having one sinusoidal waveform. So in this waveform I have taken only one part, means first half cycle 0 to pi. So in these 0 to pi all the points are having different frequency. So if I take average of all the points for one half cycle, so this is called average value. So we have to derive the value of average value for any sinusoidal quantity. So how can we do that? So for this we have to go for some steps. So before going to the step, first and foremost we have to draw one sinusoidal waveform of a current. So this is a sinusoidal waveform of a current 0 to pi and pi to 2 pi. So in this positive half I have taken one strip, elementary strip of d theta. So at this is the peak of the positive half, which is given by I is equals to small I, that is instantaneous value, which is given by I is equals to Im sin theta. So the first step 1, what I am considering that I am having one sinusoidal varying current given by I is equals to Im sin theta. All of us know this expression very well. So in the step 2, what I am considering? I am considering one elementary interval of instant d theta. Means in this positive half, I have taken one interval, elementary strip, which is having a value of d theta. Now step 3. So step 3, as per the definition of I average, what do you know? I average is the ratio of area under curve over half cycle by length of base of half cycle. So what does this mean? In the numerator I am having area under curve over half cycle. So over half cycle means I am considering the positive half. So in the positive half, how much is what is the span of this positive half? Span is 0 to pi. That's why I have taken integration of 0 to pi of I d theta. So 0 to pi I d theta means I is nothing but the instantaneous current. Okay, and I am considering this area of this part. Okay, this elementary strip. That's why I have considered it to be 0 to pi integration I d theta by what it has been given in the denominator, length of base of half cycle. So length of base of half cycle means I have taken only the positive half, 0 to pi. So what do you know? 0 to pi means 0 is my initial value, pi is my final value. So I have taken the difference to be pi minus 0, because always we know when we are taking the length of base of half cycle, so we have to consider final value minus initial value. That's why pi minus 0. Okay, now in the next step, what I am going to do? So in this formula I am going to substitute the value of small I over here. Okay, so if I substitute here, so what I am going to get? So pi I can take it out, so I am having 1 by pi 0 to pi Im sin theta d theta. So what I am doing? I am putting the value of small I, instantaneous value, which I have taken in the step 1. I has to be Im sin theta. So if I put this value, so from here what can I do? Im I can take it out. So Im by pi 0 to pi integration sin theta d theta. So integration of sin theta, what do you know? All of us we know that it is minus of cos theta d theta, having the limit 0 to pi. So if I put the value of the integration, that is 0 to pi, if I put it over here, so what I am going to get? Minus I can take it out, so minus Im by pi cos pi minus cos theta. So cos pi, what is the value? Minus 1 minus 1. So I am going to get the value to be 2 Im by pi. So 2 by pi. So 2 by pi, how much I am going to get if I take it in, if I calculate it in calculator? 0.637 Im. So while calculating this value, I have to keep it in mind. This is the most important part. So in this chapter, the pi value should be in radian always for solving any numericals. Keep it in mind. So your calculator mode should not be in degree mode. It should be in radian mode. Okay. So you change the mode of the calculator to be in radian. Automatically it will take the pi value to be as 3.14 instead of 180 degree. So if I put this value over here, 2 Im by pi, pi value to be in radian, automatically I will end up with the answer to be 0.637 Im. So what can I conclude? I can conclude that I average is equals to 0.637 Im. Means this is the current value. The same manner, if I go for the voltage, I will get in the same steps, following the same steps, instead of Im I am going to take to be as a Vm, and automatically I am going to end up with V average is equals to 0.637 Vm. Okay, so if they ask you the derivation of average value, so what you have to do? The derivation of average value means you have to derive this value to be as I average is equals to 0.637 Im. In the question, if they ask a current value, if they ask a voltage value, it should be V average is equals to 0.637 Vm. So everything should be in the same manner. If it is mentioned in the question to be current, the waveform should be in terms of current, and if it is mentioned in terms of voltage, here instead of I am going to replace it by V. That's it. Okay, so this graph is I versus T I can put, or instead of T I can put it to be as a theta also, anything you can put it, okay, for the time interval. So this is the derivation of average value. Next I am going to start up with RMS value.